In this video, we'll discuss how to take a series of aerial images, such as those collected by drones, and turn them into a variety of three-dimensional models and two-dimensional composite maps. The process that we're going to use is called photogrammetry, and it's something where software is able to find key points that are identified in overlapping images and triangulate the geometry between them to find what the three-dimensionality is in the area being mapped or with images being taken of it. There are many different options available for this kind of photogrammetry. The one that we're going to look at today in a bit more detail is called Pix4D Mapper, but there are several options available, and I definitely encourage you to try out a few and just see what you like. The reason that we're going to be using this one is that it does allow you to go into a bit more detail in what kinds of outputs you want, what kinds of inputs it can take, and things like that. So the first step is going to be to download Pix4D Mapper, and that's available through the Pix4D website. This does require you to log in, but there's a free account, or free trial period, so you can try this for 15 days and see what you think before getting a license. So we can download this here, and I'll be using the most current version, this version 4.6, and I'll be using a PC. So I've already downloaded this onto my computer, so the next step will be for me to log in. And it will prompt me for my credentials, my email and password that I set up. So then I'll log into that. And first we'll talk about RGB projects. So the first step is going to be to create a new project. First thing that we'll do here is we'll have to name the project. And we can click Next. So then all we have to do here is add our images. So we can navigate to those. And then you can take a look at these before we get started. You can see that these are just typical pictures that you'd take with most cameras, and almost any drone can mount an RGB camera. So you can just see these are just overhead images of a field with plants in it. You see that there's some irrigation ditches and things like that as well. So that's what we're starting off with. There's a series of these images. I'll go back here, I'll click Control A to, oops, sorry, let me go back, it's here. Control A to select all of those, and hit Open, and then go to Next. And then I can see here that our images have good geographic information associated with them. That's captured automatically by the camera. You go Next, yes, okay, the coordinate system looks good. It's all good to me. And then we have a few options, so these processing option templates, and I'm almost always using 3D maps. You can see that it allows images that are taken straight down, which we call nadir, or obliques, which are from the side at some angle, output quality is very high, even if the processing speed is a little bit on the slow side. There are definitely other options available, so you can definitely choose some of these other things. And one that you could try out is 3D models here. If you have a set of images, you're of course able to just try it out in both and see what you think. Maybe you'll like one more than the other. This is really tailored for really highly three-dimensional objects. You can see here, this isn't really like mapping, and the 3D maps option does allow you to create things like these digital surface models and other 3D meshes. So it's very much still three-dimensional. So that's what I'm using most of the time. But when in doubt, you can just try both out. So next we get to this screen, and this is showing us on a base map where those geotags are for our images. And I can zoom in, zoom out. I can see, yes, this is exactly where I would expect these images to have been taken. So the red dots are where each image was taken, and they're in a nice grid pattern, and that's showing the flight path, which was created with the mission planner. So that's great. And then if this isn't showing up for you, definitely just click this processing option right there. You should see a few different things here. We can go next here to processing options. And for RGB images, I'm usually not changing too much, fortunately. So we can click through these. We do have some initial processing, options, the point cloud and mesh options. But again, RGB, I'm really not changing too much in these or in general. I definitely want to create a digital surface model that'll show kind of the topography of the field. That's going to be important to me. I use those a lot. So I'm going to make sure that those boxes are checked, and especially this merge tiles. So if you don't have that merge tiles box checked, it's going to have individual parts of the field separately. So you definitely want that composite of the whole thing. We definitely want that. And so the same with the orthomosaic, we want to make sure that these are both checked here. We definitely want the whole field to be included. So then I don't usually adjust anything there, but you can see you can have extra outputs in some different formats as well. And then for index calculator, about the only thing I would normally change here is I would usually want some reflectance maps made in these different parts of the spectrum, especially if you're going to try to calculate any vegetation indices and do kind of like scientific evaluations of the plants in your field. I would definitely recommend checking this geotiff, merge the tiles, and then at a minimum, red, green, and blue. So those are all things that we do want, and then everything looks good to go. So then these outputs are things that I will use later in other software to do calculations and get a sense of things like simply canopy area or also canopy health, for example. And so I'll click OK, and now everything's ready. And we can see here there are these 3 steps that correspond to the 3 steps here from our processing options. Get back out of that. If for any reason I have run something and then I later come back and think to myself, you know what, I really meant to get some output that I didn't specify. So like in here, maybe if I hadn't checked these boxes and if I'd forgotten, well then what I can do is I can come back to my processing options and check those boxes, and I can just rerun step 3, for example. So here it's checking each box. That's showing that you're going to be running everything. But if you just wanted to create some extra orthomosaics, you can actually uncheck these if you've already done everything at these previous steps and they're good. Of course, we have not yet run this, so we're going to check all 3 of those, and it's going to go through the whole thing. So that's great. That's what we want. And then we can click Start, and usually this will take a few hours. I often just start it as the last thing I do in the day. I let it run overnight, and by the first thing in the morning the next day, it's usually going to be done. All right, our processing is now complete, and we can take a look at a few different outputs. The first thing to look at is the quality report, and this is actually going to be developed as the steps go through. So even by the end of that initial processing step, you'll have some nice outputs. And so some of the first things that we want to look at are the quality check. We want to see as many of these symbols, the green circle with the white check mark, as possible. So that's what we want to see. This is actually not a great sign that we had some difference in where the images said they were taken relative to where the processing determined they must have actually been taken. So there's a little bit of deviation there. Not critical, but not ideal either. Definitely with newer cameras, that's going to be less of a problem. This is a 2017 camera. It was purchased in 2017 at least. So a little bit older camera tends to be a little bit more common for those kinds of errors to happen. We can take a look at our orthomosaic. That's what I was expecting it to look like. That's good. You can see this is our digital surface model. That looks pretty good to me as well. Okay, and we can just take a look through these other results. This is showing that same set of where the images were taken. So the blue dots showing where the geotags were. The blue dots here again are showing where the images were. This is looking from kind of above down. And then the green dots are where the photogrammetry program determined the camera must have actually been. So you can see it from all 3 angles. This is from like the top down, this is from the side here, and this is looking from the end through it, essentially. So you can see there's some deviation. There's always going to be some deviation. That's normal, but there is, in this case, more deviation than normal. So that's fine, but maybe not ideal. Here, what we're seeing is lots of overlap, totally in the green over the whole field. So if there was low overlap in any section, you would see it as being a warmer color. And then I won't go into these in a huge amount of detail, but there are lots of other outputs. So anyway, possibly useful information. You can see, like, for example, here, what we're seeing is the number of points that were identified between images. So each image location is a yellow dot, and then like a dark bar between them shows lots and lots of tie points that were found in both those images. The fact that there's just like dark lines between all these is great. We have lots and lots of overlap, lots and lots of features being identified in tons of pictures, so that's great. And again, you can get some details of the number of points and things like that between the different numbers of images here. There's lots of detail here. We're not going to go through it all, but it's something that can be useful if you want to present that information. So I think these are some pretty neat outputs here. You can see we have different options we can select. Maybe the first thing to point out, if we get rid of all of this, is just our cameras. And again, the blue is representing where the camera was supposed to be, where it reported that it was when the image was taken, and then the green is where Pix4D determined that the image must have been taken. So anyway, kind of a neat way of visualizing where all these pictures were taken and what the camera was seeing and where. So I think that's kind of neat. Then we can add in our tie points, and down here we can see for any given area, we can click on it and see where that was showing up in different images. So I can just click, this is pretty much the corner of the field, at least in terms of plants, and we can click on it and we can see all of the different images where this was showing up. So the green line is showing that it was picked up in a picture. We can also go over here and see those and this kind of thing. So kind of neat. You can look around in that and see that, yeah, it looks like it's maybe at the edge there. We could click over here, for example, and that looks like there's a pipe. Yeah, sure enough, we can see a pipe in these images. Okay, great. So that's one way of visualizing the field there. We can also go through and show a more densified point cloud of the whole field. If you ever want to remove those cameras, for example, you can get rid of those by unchecking the box in the layers panel. So again, this is still a point cloud, and it's a highly densified point cloud there. And so this is actually something you can download, the locations and the colors of each of those points if you want. And maybe in some cases it's useful to do that, to get information, like very detailed information about all these different tie points. But for visualization, which is what I'm usually using this step for, I actually think the triangle mesh here is maybe the neatest of them. So we can just get a nice, not point cloud in this case anymore, but a nice visualization. Make sure let's uncheck that tie points. Yeah, so now there aren't any points there, but we can see our field and the three-dimensionality there. And to me, this looks good. So it's definitely what I was expecting to see here. Okay, great. So again, this is mostly something I'm using just to kind of check the quality of the outputs. And yeah, I mean, you can just see the three-dimensionality in those images. Some of these, I'm wondering if maybe some obliques would have helped with showing the sides a little bit better. But overall, it looks pretty good, and much of what I'm doing is based on top-down. Anyway, okay, so then now let's take a look at our outputs, and those are mostly going to be stored in the Documents folder by default. Pix4D will create a folder within that, and then we can go to our outputs here, and we can see that we have these different options. And what I'm working with most of the time is going to be either here in this digital surface model and orthomosaic folder, or in the index folder here. Index. So let's go through this digital surface model, in here we can find that. If we just try to open that on its own, we might find that we will find that it usually does not show up very well in one of these photo viewer kinds of programs. So I'll open up QGIS and it'll show up nicely there, but I'm just going to get out of that for a second. Let's go over to our orthomosaic, and this should definitely show up looking very nice in a photo viewer. That's good. That's going to be very useful, I think, even just for like reporting. If you're going to go and give a talk about your work, it can be very nice to have a high quality orthomosaic like this of your field. Maybe just rotate this a little bit, and then we can zoom in. We can see the field. So for RGB, it especially, it's really nice to have something that looks natural, because if you're doing this with a multispectral camera, you're not usually going to get a kind of natural color view of your field. So this is kind of a nice image. And then as far as our like vegetation indices go, we would have to go into these and we can find our red, green, and blue maps. Again, these are going to have each pixel with reflectance data in it, and that's not going to be formatted in the same way that a photo viewer app usually would expect the data, so it'll often not appear very nice or very clear. So again, just for the purposes of demonstration, if we do want to check the quality of our digital surface model, for example, we can go back, or these other index maps, those are best visualized in something like QGIS. You can just download this and then literally just drag and drop, and it'll load there. And now, even though it didn't show up well in our photo viewer, this program, QGIS, which is free, allows you to see it nicely. And so that is the reflectance in the red. You can go back to DSM Ortho and grab our DSM, our digital surface model, and drop that in there. And then here, this is showing the map of the field, showing the higher level areas in lighter colors, and sure enough, the tops of these plants are showing up as higher. Uncheck that. Showing up as the lighter color, indicating that they're higher. So these kinds of outputs can be then used for further downstream processing, which we'll talk about in another video. Next, I wanted to talk about the processing of multispectral data using Pix4D, and the process is mostly pretty similar. So we can start off by creating a new project. We'll have to name it. And then we can, once again, choose our images. And here often we'll have multiple sets of images, multiple directories, because often with multispectral cameras we're getting lots and lots of images. They often are going to be a little bit smaller in size, but often because you have maybe 3 to 5 or more bands, like wavelengths that you're getting images of, then often you do have this larger number of images stored in different directories. So I just went through and selected all of those. So we have 2800 here, and click Next. It's reading in those geotags now. And now we can take a look. We see that they're all geolocated properly. That's great. That's what we would expect. This looks like the right latitude and longitude. That's good. Okay, good coordinate system. And then here we'll have to choose our template. And what we'll want is our ag multispectral here, the standard, not rapid version. And then we can click Finish. Great. And so once again, we want to go into our processing options. And usually I'm not changing these first two, but definitely in this third one, we want to go through and check our options For me, the digital surface model is very important, and I do want to check both of these boxes for geotiff and merge tiles. And I think it can be useful sometimes for demonstration purposes, especially to have an orthomosaic as well. That can look nice for presentations or whatever. And so then here, index, this is super important. And here we're going to actually calibrate the model here. So we can go in, and it's great that the most recent versions of Pix4D do this automatically for you. So we took some images that day of a calibration panel of known reflectance value, and it has a QR code on it, and this software can automatically recognize it, find that panel, and it knows what the reflectance is. So this is great. We used to have to do this manually. But yeah, this is awesome. We just check these. If for any reason this QR code is partly covered or something, it won't read this in. So we just want to make sure that it's being read in. Those are all, that's perfect, that's great. So then we can, so we can go through this. I definitely want to merge those tiles. I don't know why the default would be to just get individual parts of the field. I definitely want reflectance map of the whole field. And then you can choose if you want to have indices calculated. I usually am going to use NDVI, but if you want to do other vegetation indices like NDRE, which maybe if you've heard of it, it is less susceptible to saturation than other types. But for today, I think that it's fine to just have these this NDVI index being calculated, and we'll proceed here and click OK. So again, this is showing that nothing has been processed. It's all in the red, and we're going to just go through all these steps from beginning to end and click Start there. Again, this usually is going to take a few hours. I usually get it set up as the last thing I do in the evening. I start it running, and then I come back the next morning, and it's usually completed. So now our processing is completed for our multispectral images, and we can take a look at the results. First thing that we'll see is this quality report, which is similar to what we saw with the RGB imagery. You can see here that we have lots of tie points. All of the positions look great. This is exactly what we want to see. We know already that, yeah, we didn't use any ground control points. This is a nice field scale digital surface model. That's great. These are the 5 different wavelengths that we were capturing images of, and we can see nice field models of all of those. So this is exactly what I want to see. This is great. Again, this is just showing the positions of the camera that were reported in the geotags. Here we can see that there is some small difference in some images between where the camera was reporting that it was when it was taking the picture versus where the Pix4D says it must have actually been based on the geometry of the images. But the difference is real small. And you can see it, especially like in some of these passes, it's almost indistinguishable. So that's great. That's exactly what we want to see. There are these few points here in red that's showing that it's not an image that was used to create the model, is basically thrown out, and those are actually our calibration panel images taken on the ground. So again, this is all looking very good to me. Lots of overlap. That's great. This camera has a pretty good GPS on it. I think that really helps with making these look nice. So again, there's lots of detail here. You can get information on things like how many tie points were found between different numbers of images. So we have lots and lots of tie points found in just 2 images, and smaller numbers of tie points found in greater numbers of images. That's fine. That's what we want to see. This all looks good to me. Okay, so that's enough with the quality report. Now we can take a look here at the point cloud and the camera and array information. So yeah, we can see this is a nice field model. We have all of our camera images and all the information from those. So yeah, this looks very good. That's totally what I'm going for. We can find information about these in the Documents folder. We go to Pix4D. We can open our folder, and again, we can find digital surface models here. Those can be opened up in something like QGIS. You can get nice information from those there. We can also find our orthomosaics from each of the different wavelengths that we were capturing with this camera, and we can find our index information here. So we have this NDVI map as well. So anyway, these are some of the tools that are available to create nice 2D and 3D models, and then usually you're going to take those and you're going to open them up in something like QGIS or other software, and then you can do more calculations with them. You can start extracting data, and that'll be covered in other videos. I hope that you found this video useful. Thanks for joining, and we hope to see you again.